Dear students, under the topic vector analysis, the first concept that we are going to learn is vector differentiation. So, under vector differentiation, first we are going to learn about the directional derivative. So, the directional derivative of a scalar point function phi of x comma y comma z at the point p of x comma y comma z in the direction whose direction cosines are L, M, N is given by L multiplied with the partial differentiation of the scalar point function phi with respect to x plus m multiplied with the partial differentiation of the scalar point function phi with respect to y plus n multiplied with the partial differentiation of phi with respect to z. So this is the formula for directional derivative when the direction cosines are given. So that we have to note very importantly. So whenever the direction cosines are given, then we have to use this formula because we have another formula by using the gradient of a scalar point function, which we have to use when the unit vector is given, which I will explain in our future videos. So remember, the directional derivative of a scalar point function whenever the direction cosines are given is given by this formula. So let us do problems under this topic now. So let us find the directional derivative whenever the direction cosines are given. So now here we have the first problem under this topic. Find the directional derivative of x square plus y square plus z square at the point 3, 6, 9 in the direction whose direction cosines are 1 by 3, 2 by 3 and 2 by 3. So now here the direction cosines are given. So whenever you see this word, that is the direction cosines, then we have to use the formula L multiplied with dou phi by dou x plus m multiplied with dou phi by dou y plus n multiplied with dou phi by dou z. So where the value of L, m and n are 1 by 3, 2 by 3 and 2 by 3 because L, M, N are the direction cosines. And what are the direction cosines over here? These values. So this is L, this is M, this is N. And what about this? This is the scalar point function phi. So this is the scalar point function. So we have to evaluate the directional derivative using these data. So let us do that now. So first of all, let us take and write the scalar point function that is given to us. So what is the scalar point function? That is phi, which is equal to. So this is the scalar point function which is given to us. X square plus y square plus z square. So we have to take and write that. Now in order to use this phi in this formula, we should know what is dou phi by dou x, dou phi by dou y and dou phi by dou z. You can either do it directly in the formula itself or find each of these values separately and substitute here. To make it simple, first I am going to find these values separately. So first let me find dou phi by dou x. So by differentiating this phi partially with respect to x, we get dou phi by dou x to be equal to. So when we differentiate this partially with respect to x, y and z will be treated as constants. And so on differentiation they become 0. And what about the differentiation of x square? It will be 2x. In a similar way, we have to differentiate phi partially with respect to y. The same thing, that is x square and z square will be treated as constants, and on differentiation they become 0, and the differentiation of y square is 2y. And also dou phi by dou z we have to find. That is, we have to differentiate phi partially with respect to z, on which x square and y square will be treated as constants, and on differentiation they become 0, and the differentiation of z square is 2z. So we have obtained dou phi by dou x, dou phi by dou y and dou phi by dou z. We have to substitute each of these values in this formula now. So therefore, the directional derivative, shortly I'll represent it as dd. So the directional derivative is equal to, first we have to substitute L. What is the value of L? I told you it is 1 by 3. So 1 by 3. And what is dou phi by dou x? We have evaluated it as 2x. So 1 by 3 multiplied with 2x plus, what is the value of m? M is 2 by 3. So 2 divided by 3 multiplied with the value of dou phi by dou y, which is 2y, plus n. What is the value of n? It is 2 by 3. So 2 divided by 3 multiplied with dou phi by dou z, which is 2z. So we have to substitute 2z over here. Therefore, we obtain this as directional derivative is equals, here it is 2 by 3 x plus, so here it is 4 by 3 y, plus here also it is 4 by 3 y. Now I'm in z. So then what we have to do is, here the question is, read it carefully, we have to find the directional derivative of this scalar point function at the point 3 comma 6 comma 9. So they have given the values of x, y and z. So what is the value of x? It is 3, y is 6 and z is 9. So at this point we have to find. So therefore the directional derivative at the point 3 comma 6 comma 9 we have to find, which will be equal to, we have to substitute the values of x, y, z over here. So first it will be 2 by 3 multiplied with x. What is the value of x? It is 3, plus 4 by 3 multiplied with y. The value of y is 6, plus 4 by 3 multiplied with z, and the value of z is 9. So we have to substitute 9 over here. So we shall simplify this. 3 and 3 gets cancelled here. This is 3 1 times and this is 3 2 times. 3 1 times and this is 3 3 times. And so the final answer will be equal to. So what will be this? This is actually 2, and plus here 4 2 times is 8, plus 4 3 times is 12. And on adding all this, what we get is 22. So therefore the directional derivative at the point 3 comma 6 comma 9 is equal to 22. So I have taken and I have written the answer. So if you see, directional derivative is a value, which means it is a scalar value. So the directional derivative is not a vector, it is a scalar. So we will see one more problem of the same type. So now here we have the second problem where we have to find the directional derivative of the scalar point function x plus xy square plus yz cube at the point 0, 1, 1 in the direction whose direction cosines are 2 by 3, 2 by 3, negative 1 by 3. So if you see, the direction cosines are given. So whenever the direction cosines are given and the question is about directional derivative, then the formula that we have to use is directional derivative equal to L multiplied with dou phi by dou x plus m multiplied with dou phi by dou y plus n multiplied with dou phi by dou z. What is the value of phi? The value of phi is the scalar point function which is given in the question. So let us take and write that. And what are the values of L, M and N? It is L is 2 by 3, okay, and M is 2 by 3 and N is negative 1 by 3. They are the direction cosines. Now we shall find dou phi by dou x, dou phi by dou y and dou phi by dou z for the given scalar point function. So on differentiation of phi partially with respect to x will be equal to, so the differentiation of x is 1 plus this y square has to be treated as constant and the differentiation of x is 1, and so it will be 1 into y square, which is 1 plus y square. And this becomes 0 as these two terms, or that is y and z, will be treated as constants. In a similar way, we have to evaluate dou phi by dou y, which will be equal to, on differentiation x becomes 0 and this on differentiation will give us 2xy plus this on differentiation we will have z cube, because z is treated as constant and so it will be only the differentiation of y is 1. In a similar way, we have to find dou phi by dou z, which will be equal to, these two terms become 0 as they do not have a z, and here the differentiation of z cube is 3z square, so it will be 3z square multiplied with this constant which is y. So now we have found dou phi by dou x, dou phi by dou y and dou phi by dou z. The next step is we have to substitute each of these values to find the directional derivative. So in this formula we have to substitute. So therefore the directional derivative will be equal to, so the directional derivative is equal to, first we have to write L. L is what? 2 by 3 multiplied with dou phi by dou x is 1 plus y square plus m. So m is 2 by 3 multiplied with, what is dou phi by dou y? It is 2xy plus z cube plus n. What is n? It is negative 1 by 3. So negative 1 by 3 multiplied with dou phi by dou z, which is 3z square y. Now we have to find directional derivative at the point. The point given here is 0, 1, 1. So here the value of x is 0, y is 1 and z is 1. So we have to find the directional derivative at the point 0, 1, 1, which is equal to, so at the place of this will be 2 by 3 multiplied with 1 plus, what is y over here? It is 1. So 1 square is 1. So 1 plus 1 will be 2. So first I will write this 1 itself. So then 2 by 3 multiplied with, the value of x is 0. So this full term becomes 0 and z cube is 1 cube, which is 1, plus negative 1 by 3 multiplied with, here the value of y is 1 and z is also 1. So it will be 3 alone here, because 1 square multiplied with 1, we will be left out with this 3 alone. And so finally this will be equal to 2 by 3, and this is 2 plus 2 by 3 and minus this 3 and 3 gets cancelled and it will be minus 1. And so further it is 4 by 3 plus 2 by 3 minus 1. And here the LCM is equal to 3, and we will have 4 plus 2 plus negative. This 3 has to be multiplied with this 1, so negative 3. And so the answer will be equal to 4 plus 2 is 6, 6 minus 3 is 3, and so it will be 3 by 3, which gets cancelled, and this will be equal to 1. So therefore the value of the directional derivative at the point 0, 1, 1 is 1. So therefore this is the answer. So I have taken and I have written the answer here. Hope you have understood both the problems under this topic. In our next video, we will learn about gradient of a function and continued with the directional derivative using the gradient of a function. So let us see that in our next video. Thank you.